Right, good morning Year 9. I've decided to go back and do a little video for each of the lessons that I've done for this week, because a few of you have been in touch and said that you're finding it a bit tricky, so hopefully this will help. If it does, please get in touch and let me know. If it doesn't, also let me know, and then I can come up with something else. Okay then, so you've done circuits before in other years, and there's lots of different models that we use to describe how circuits work. And one of the really common ones is that it's a bit like central heating in your house. So in your central heating, you've got a pump that will push the water around once it's been heated. Once it's turned on, the pump starts to work and it pushes the water through the pipes. And once it's working, all of the water is going to be flowing at the same time. So at any point in your central heating system, water is flowing through the pipes at the same time. There's no gaps where it's just sitting there. Okay. When it gets to the radiators, then there's a transfer of heat. So basically the boiler heats up the water, and that water is carried to your radiators, and then it transfers that heat into the room, and then it returns back to the boiler to be reheated and repumped around again. And an electric circuit is virtually the same idea. So in this case, you've got a circuit set up, you've got your cell, you've got your wires, and you've got your lamp or your bulb. Now in this case, the bulb is a bit like the radiator in your house. Any component transfers energy that's coming from the battery, and it transfers it into another type of energy. So in this case, the bulb will transfer energy into light, which is useful, and heat. Okay, so rather than water flowing through pipes, this time you've got electricity that's actually going to flow through the wires. But the wires behave like the pipes. That's where the electricity actually flows. And the flow of electricity is called the current. Now the current is pushed around, rather than a pump like in your central heating system, the electricity is pushed around the wires by the cell or the battery. Now, in this case, a cell is quite specific. We would call a battery, but that is normally shown as multiples. It could also be the mains electricity or a power pack that you'd be used in class. So the energy and the push that's provided by that's what we call the voltage. Now, to make a circuit work, you need three things. So first of all, you need to have a power supply. So you need something to push the electricity around. So it could be a battery, it could be a power pack, or it could be your mains electricity that you plug things into in the wall. You also need wires for the electricity to travel through, and you would need a component, a device. So it might be a bulb that will transfer energy into light and heat. It might be the radio, which transfers it into sound. It could be a motor, which transfers that energy into movement. Now, not all materials will allow electricity through them. So some materials will. Those are called conductors. Metals are particularly good at conducting. And if they don't let electricity through, then they're called insulators. And plastic is a really good idea, or a good example of an insulator. That's why on electric cables, the metal on the inside is designed to let the electricity flow through it, whereas the outside is covered in plastic so that you don't get an electric shock off the wires. Now, metals are able to conduct electricity because they carry, or they have, electrons that are able to move. Now, if you look at the diagram, the little grey spots here, which are positives, these are the metal ions. Okay, they're all held in place, but in between those ions you have tiny electrons. Now these are able to move and flow through the metal. We call them delocalized, and when they move and flow, that is what is happening when you have an electric current. Now if it's an insulator, they don't contain those electrons, so if the electrons can't move, it can't carry a current. Now, some materials that are ionic, that relates to your chemistry, are able to conduct electricity when they're dissolved in water, because when they're dissolved in water, the electrons are able to move. Okay, but mostly metals are particularly good at conducting electricity. Okay, now sometimes when you set up a circuit, and I'm sure you have done in class, you'll set everything up and the bulb doesn't light. Sometimes it's because the bulb's broken, but sometimes you've got the wires a little bit wrong. Okay, now something that you need to know is that electricity is very lazy. It will, if it has to flow through a component, it will do so, but if it can choose not to, if it can just flow along a wire because it's easier, then it will do that, and that's called a short circuit. Now in this first diagram, if you follow it around with your finger, okay, the electricity comes out of the battery, it follows one loop, it can only pass through the bulb, and then it goes back again. Okay, in these other circuits, it's got a choice. It can go somewhere easier, and it will do that. So in this case, it will flow around. Once it gets to here, it thinks, oh, I can't bother to go through the bulb because that involves me doing a bit of work. So I'm just going to go straight through that wire, and it will flow around. So electricity will flow around here, but the bulb will not light. This is called a short circuit, okay, because the current is flowing, but it's not going through the component, and they can actually be quite dangerous, so you need to be very, very careful with short circuits. This one's exactly the same, okay, so it will come round here, rather than going the long way around through the bulb, it will actually go through that wire, and that is also a short circuit. Okay then, so the different components, you should be quite familiar with these. This is the inside of a computer. Now if you were going to try and design this or put one together in a factory, it would be very, very complicated. They're tiny, tiny parts, and there's lots of them. So to try and explain how we assemble things, we use symbols, okay? And that it provides us with a bit of a sort of schematic idea. You're familiar with them all, but it makes it much easier to put circuits together, okay? So some of these are listed below. You should have gone through all of these. Each of these buttons will tell you a little bit about each of the components that you need to know, okay? Now the switch one, a circuit will only work as long as the switch is closed, because if it's open, then there is a gap, okay, and if there's a gap in a circuit, then electricity can't flow, okay. But the other components, I'll let you go through those yourselves and make some notes on them. Okay, right, when we come to draw circuits, they look like this in terms of they've got wiggly wires rather than nice straight lines, okay, but we can make that into a much simpler diagram by using symbols. So you've got two cells. I know we would normally call these batteries, but these are two independent cells. So you would draw two cells joined together with a bulb, and we make it into a square just so that it makes it a bit more simple to understand. So that would be drawn like this. So you've got your two cells, okay, they need to be in the same order, like when you put batteries into a device or something, and then you've got your bulb there, okay. The next one, this time you've got the two cells again, but this time you've got two bulbs. So all you would do is you just make a slightly bigger square, or you'd make a bit more space, and you would put a second bulb into the diagram, okay. Now this circuit is slightly different in that it is a parallel circuit. Now series circuits have one loop. The electricity has only got one choice of which direction to flow. So these two circuits that we just looked at are both series circuit. There's only one loop. So if you follow it around with your finger, magic electric fingers, you go all the way around, it only has one choice to go through, okay. The same with this one. Even though it goes through two bulbs, it still only has one choice or one route that it can go through. When you come to a parallel circuit, what happens is that you have branches, and there is a choice or a different route that the electricity can flow through. So it will start off here. When it gets to here, it can go either through this branch or it can go through this branch, and as it comes round, it joins back together, okay, to go round. So that is a parallel circuit, okay. Now in this one, what you need to do is have a look at some of the circuits, okay. Some of them will work, some of them won't, okay. So you're looking for things like a gap. You're looking for if it is a short circuit. So remember that if it can just flow through a wire rather than through a bulb, then it will do, okay. You need to make sure that the batteries are the right way round, and that they actually have a battery. So you should have had a little go at which of these circuits work and which ones don't. Okay. So in this case, you've got a circuit set up. Now you need to, the switch is open at the moment, so it definitely won't work for the time being. Now when you close that switch, you need to think about what will happen. Again, if you need to, follow it around with your finger. So start at one side of the battery, follow it around with your finger, and if you come to a junction in the wires, think about where the electricity will go. Is it going to be lazy, or is it going to go through something? If it's lazy, it's going to be a short circuit and it will go that way, Okay, so in this case, it's going to come round here. When it gets to this junction, it's not going to go through the bulb, it will go round here. So the current will still flow, but the bulb isn't going to light. Okay, so this would be a short circuit. And to correct that circuit, we'd need to take out that spare wire. Okay, right, now I hope that helps a little bit in terms of what happened for this lesson. There are some sheets for you to complete, and if you can't do them, then send me an email. Okay, see you later.